This is section 5 of chapter 2b of Probability and Statistics. Our topic today is comparing distributions and choosing numerical summaries. Our essential outcome is that you'll be able to compare box plot distributions and choose numerical summaries for data sets. So before we get into numbers, we're going to look at a picture. So here I have two pictures, and what I want you to do is compare and contrast the two photos. In these two photos, I'm going to tell you there are 4 differences. Why don't you pause the video now and see if you can find those. Alright, now you should be able to see the differences that I found. The steeple's missing on the dome. The antenna's missing over here as well. We've got no lady here, and all of a sudden there's a lady that shows up. We've got a person down here who's not over here. And so, when we do pictures, you've probably done pictures like this as a kid where you compare and contrast, try and find all those differences. And that's kind of what we do with data, what we're going to do with data today. And so some words we talk about, we can compare and contrast. Words we talk about things being shorter, taller, larger, smaller, wider, skinnier, longer, or them being the same, equal, equivalent, identical. So those are some words we use. And we also talk about we discussed the minimum and the maximum, and the interquartile range, the outliers, the median, quartile 1, quartile 3, the spread, the shape, and the average. And so these are all words that we can use then to discuss two data sets and to compare and contrast them. And so if I look at this next slide, I've got 2 box and whisker plots, and I can compare these 2 box and whisker plots. This one goes from 5 to 12, and this other one goes from 6 to 15. So their ranges are different. The first one has a range of 9, set B has a range of 9, set A has a range of 7. Set A has a median of 7, whereas set B has a median of 10. Set A's quartile 1 is smaller than set B's quartile 1. Its minimum is the minimum of set B is smaller than the minimum of set the minimum of set A is smaller than the minimum of set B. And so we can start to compare and contrast some of these different things. It looks like the interquartile range is the same on both of these though, which is an interesting thing. And so that's an example of how we would compare and contrast two data sets. And so here we have 3 box and whisker plots shown again, and they show the income of SRSs of size 50 from 3 groups of adults with 3 levels of education. Those with advanced degrees, those who stopped at the bachelor's degree, and those with only a high school diploma. We're going to write a description of the relationships between education and income in these samples. So set A, this is just a high school diploma. Set B has a bachelor's for the highest degree, and set C has an advanced degree. So if we compare and contrast these, well, set A looks like it has a bigger range than set B. Okay, but set B has a higher median than set A, and it even looks like it might have a higher median than set C. Let's look at that set C now. Wow, set C has the largest range. Look at those quartile 3s. Well, set C has the highest quartile 3. But look at B. Set B looks to have the highest quartile 1. Let me scroll this down. B has the highest Q1. So these are all some different things you can compare and contrast about them. It's kind of interesting. You might have noticed a few other things. Set A's IQR is the smallest, set C's is the biggest, so it makes set B in the middle. Of all the ranges, set B has the smallest range. I'm guessing for set A and set C, they may have some outliers that were not actually calculated here, because I don't think this $300,000 income is consistent with the rest of this box and whisker plot. And so here are some things we need to know. Basically, we're going to talk about when we have skewed distributions. So when you have a skewed left distribution like this, where your teeter-totter is going to go up left if you were to put this distribution on a teeter-totter, the thing that happens with the mean is the average of all the data sets. And so if you have a mean, if you have an outlier in your data set, your mean is going to really significantly feel that, and it's going to be skewed. So sometimes our mean or our average is not always the greatest measure of center for us. Sometimes we need to go by the median, because the median is the actual middle of all the data set. And we represent that median with a big M. And so sometimes our best measure of center is our median. And our measure of spread, well, measure of spread, that's either our IQR or our range or our standard deviation. And if you think about it, okay, well, standard deviation is calculated using the mean. So we probably, if the mean is skewed, we probably don't want to use the mean, and we probably don't want to use the standard deviation for our measure of spread. So instead we use the IQR because that's really shows us the middle 50% of the data. And once again, it's the same thing when it's skewed right. That mean is being affected, so we use our median instead. And for our measure of spread, well, that range or that standard deviation is being affected as well, so we stick with the IQR. So when you have a skewed distribution, the things that are not affected are your median and your IQR, and so we use those to measure spread and the center. However, if you have a symmetric distribution, your median and your mean, if it's truly symmetric, these are going to be the same thing. So it doesn't really matter which one you use. We can use both if the computer would let us. So we can use either one. Whereas our measure of spread, if this is roughly symmetric, we can use both of these as well. We can use a standard deviation or the IQR. Either one is going to work. So ask yourself once again, if your data set includes outliers, what should you use? You should use the median and the interquartile range. So that is the end of Comparing Distributions, Lesson 5 of Chapter 2b. Make sure to write your summary and questions. Our essential outcome today was that you will be able to compare box plot distributions and choose numerical summaries. Things to think about: how do I compare two box plot distributions? How do I decide which numerical summaries to use to describe the distribution?